We're ready to go here, folks. I'm welcoming today Brendan Gray from Ignite Sustainability. Brendan is local to Kelowna. He is an EA, so please don't rush the stage. And Brendan's going to take us through some information about how EAs operate, some step code applications, and how fenestration works within the EA's world and fenestration design. Okay, so welcome, Brendan.
Thanks, Terry. Alrighty, good morning, everybody, and thanks for taking the time and listening here today. As Terry mentioned, my name is Brendan Gray. I'm the owner of Ignite Sustainability. I'm a local energy advisor here who specializes under Part 9 of the Building Code, and also I'm an integrated design facilitator too. So we do specialize in doing a lot of high performance, step 4, step 5 homes as well. And with our local Home Builders Association, with our step code committee, we are hearing your guys' concerns regarding the high solar heat gain, which is getting spec'd in some compliance reports that are getting sent out there as well. So I got some case studies I'm going to be going over with you guys as well, to showcasing what it does to the metrics to benefit it, and then some of the downsides too for overheating, especially in the summertime. So some of the discussion topics I'm going to be going over with you guys here today. What is the BC Energy Step Code? I understand Scott kind of went through that with you guys already. Again, I'm just going to go over some high-level stuff that he might have missed, just pertaining a little bit more to our industry as energy advisors. Some of the implementation updates to those of you who maybe are new here to BC, how to read those pre-construction compliance reports, and then we're also going to be reviewing the changes that rolled out as of May 1st. We've got an updated template there too. For how we're working through on the pre-construction side as energy advisors working with builders. We're going to be going over building orientation and passive solar gains, how that affects the step code metrics. We're also going to be reviewing building envelope upgrade optimizations. And I'm going to end on the integrated design process and some of the incentives that are out there and going through the process and how it could benefit you and your clients and engaging in those services there too. So what is the BC Energy Step Code? And, I'm not going to cover on this too. I'm going to go over at high level. Again, it's in support of the BC Climate Action Plan that was adopted back in 2017 and 2018. And the overall goal is to reduce our greenhouse gas emissions in buildings. And, buildings do account for around that 35 to 40% of our annual greenhouse gas emissions per year. And, the way the province has things laid out, we're trying to get to net zero carbon ready by 2030 and then net zero ready by 2032. So some pretty aggressive timelines that we have coming up in a short amount of time. We also, the nice thing about the step code, it's a consistent approach to advancing energy efficiency. So we'll have the same modeling guidelines and procedures which we're following just to keep consistent in the industry. So, we got the lower steps 1 to 3, and as of May 1st, we're all at that step 3 requirement. And even municipalities that adopted step 1 were going through the process, working with energy advisors or working with builders. A lot of those projects were already hitting step 3 without really, having to do very much in the way of any upgrades. Builders were already achieving good air tightness, and window suppliers were already, providing really good window packages to industry. And quite often we're hitting those step 3 requirements. As we move to step 4 and step 5, those are the upper level steps. So that's when we got to get a little bit creative in, how we're targeting air tightness, our insulation, what we're speccing for windows, looking at that balance between going from a high performing double to triple glazing. So there's basically 3 metrics that we have to adhere to under Part 9. I'm going to be focusing mainly on Part 9 of this presentation today. We got the building envelope metrics, mechanical and system metrics, and air tightness. Scott touched on this one, but I thought I'd just quickly go over this just one more time. For the building envelope metrics, we've got losses. So that's everything to do with air leakage, and then heat loss through the insulation, through the windows, in the basement. But we also got the benefit of, gains, passive solar gains. That's that passive solar heating, right? So that's how we're orientating those buildings, what we're speccing for solar heat gain. Obviously, a higher solar heat gain is going to improve the energy efficiency, but we got to watch out for the comfort aspect in the summertime associated with that. Some other gains which benefit the metrics is people and equipment. So under the multifamily, the infill projects, where we've got multiple people in the building, that's additional internal heat gains. That's making those buildings more energy efficient as well. So that's benefiting our step code metrics, the gains. Energy usage is pretty straightforward. That's everything to do with our mechanicals, our heating systems, domestic hot water, ventilation. And then we also got our air tightness testing. So we have to meet all three metrics of each one of those individual guidelines in order to hit a certain step code level. So some implementation updates. As Scott mentioned, we're step 3 come province-wide under Part 9 of the building code. And now we also have this opt-in zero carbon step code. And the only real area that has adopted the zero carbon step code method is area, I think it's in Victoria right now. So municipalities are still, consulting on when they're going to be adopting that guideline. But basically, it's intended we're going to be moving towards being, net zero carbon by 2030. So that's basically operating solely on electricity. So again, some pretty aggressive targets coming up in the way how we're going to be, targeting fuel types being spec'd on buildings. We also have the prescriptive energy efficiency approach, what Scott touched on. We've got the revised compliance report template, which I'm going to show some examples of how to read through those. And then we also got the updates to the building envelope to heat loss % better metrics and changes in regards to that too, which I'm going to cover here right now. So as what Scott mentioned, under the prescriptive energy approach, we got that 1.22 for our windows, for that updated metric for municipalities or jurisdictions that have adopted the prescriptive approach. And then under above grade opaque building assemblies for the flat roofs, they've been now broken out separately out from ceilings and roof decks. So they've got their own. There's increases in performance underneath flat roofs now for the prescriptive approach. And then our exterior walls, they've also got some increases for performance there as well, underneath the above grade opaque assemblies. So those of you who are familiar with the BC Energy Step Code, you're probably pretty familiar with seeing this pre-construction compliance report here on the left. This is the revised compliance report that we're now utilizing for all building permits that are going in as of May 1st. So a bit of a revised breakdown for how we're providing these, and I'm going to be going over this in a little more detail on some upcoming slides. Under the Energy Step Code compliance metrics, we used to have building envelope % better. And the one thing with the building envelope % better, it was accounting for passive solar gains. So if we had a building which had majority of the windows facing south, it was passing quite easily underneath building envelope % better target. That has now gone away underneath the revised metrics. We now have building heat loss or % heat loss reduction. So that % heat loss reduction does not account for solar gains. So it's not a bit of a cheat to the system where, if we're having a window supplier, or an energy advisor speccing a very high solar heat gain, it's not an easy system to pass now under step code underneath this % heat loss reduction, which is, really good for industry as well. So this is the revised compliance report. And still, we've got the project information up top there regarding everything to do with where the project's located. And one of the big things that's changed is we've now got a code compliance summary. So this is a breakdown, so you can see right on that front cover page, what is the prescribed target for that municipality is hitting, and then what proposed level that the builder is trying to achieve. We also got the zero carbon step code laid out here now too. So we are measuring those on all projects as of May 1st. And once municipalities start targeting a required metric, then we're gonna have to start meeting the zero carbon targets there as well. Section C remains the same, who the compliance report was completed by. On the second page, we've got building characteristic summary. So this was one of the biggest complaints we had from energy advisors and also industry. We didn't have enough information that we could put in those compliance reports. So now we got a full page to comment on multiple line items for what we've got for roof ceiling, above grade walls, rim joists, floor headers, walls below grade, slabs, windows and glazed doors. I'm going to be touching on that in a little bit more detail. Air barrier system location, space cooling, domestic hot water heating, and ventilation. So we got a full page for now specs that we can go through and provide more detail. For like patio doors? We do, yeah. So typically, if it's like a simple spec home and we don't need anything too crazy for a window package, we'll do something like this, where we'll just spec like an average window performance value of like 1.6 and 0.26 for a solar heat gain. So as long as the average package is meeting those requirements, it's fine. But if we've got, maybe a project that needs a little more detail, then now we can break these out and say, the fixed windows should be targeting around this area. Our casement windows 1.42, patio doors 1.59. So then you guys get a bit more of a better idea what's in the model. And usually what we do with this too is, this is just a baseline, and you guys can provide, your quotes, your window schedules. Once the builder selects going with a particular window supplier, we update that window schedule or that window quote with your specs in the model, and we'll make sure we're in alignment there too. So these are just baselines to get the conversation started, because obviously you guys have different specs for what you guys can provide for what types of windows that you're going to be installing as well. Under section F, this is the 9.36.6 energy step code compliance. So this is the performance pathway metrics here. And then we've got at the bottom the zero carbon step code metrics, which is the new metrics we're now adding into the mix associated with the zero carbon code. Alrighty, I'm going to be moving into building orientation and passive solar gains. So just to recap, regarding some building science practices that we always look for when we're trying to achieve like a high-performing step 4 and step 5 building. Anytime we can orientate majority of the windows facing south, and we can capitalize on good overhangs, that's the way we build, the most cost effectively to the upper level steps. Because in the summertime, basically that sun sits higher up in the sky and the roof access. So if we've got the right overhangs, we're providing good shading to our homes. As that sun sets, as we move into the fall and winter time, then we can capitalize on, taking advantage of passive solar gains, because those passive solar gains are offsetting our heating demand in the wintertime. And again, here in the Okanagan, we're in a heating dominated climate. But the thing we got to watch out for is that in the summertime, we get some pretty extreme temperature fluctuations and we got risks of overheating. So we really want to be careful with, what solar heat gain that we're speccing on certain facades of the window. And even on some high performing like passive house homes, step 5 homes, we're actually really working with, the energy advisor, the window supplier on, looking at solar shading analysis and what windows we can expand on a higher solar heat gain window, and which ones we have to spec on lower solar heat gain too. So a lot of times what we're seeing is we're seeing a blended, average being applied around all the windows. As we start moving towards these higher level steps, we've got to get a little bit creative on the windows that we're speccing on what facades of the home as well. Another important thing is working with the architects too, discussing, horizontal shading strategies too, overhangs. And then we can also look at doing vertical shading strategies too, say on west-facing facades and whatnot. Working with landscape architects and speccing deciduous trees as well for those west-facing projects where, in the summertime, those projects, they're going to provide shading from those leaves on those trees. In the fall and winter, they're falling off, and we can benefit from the solar heat gains in the wintertime. So this is a bit of a case study I got for a project here in the Okanagan that's going on up at Towers Ranch. And we've got on this particular home, it's a single-story walkout basement. And we can see here this is a pretty common occurrence that we have in the Okanagan, west-facing windows, facing the city, facing the lake. This particular project has got 59% of the windows facing south. And then we've got on the front elevation, 19% of the windows facing east, the right side, 7% windows facing to the north, and then 15% of the windows facing south. So I know it's probably difficult for you guys to see in the back there what it does to the step code metrics, but this example I wanted to go through with you and showcase, what happens when we've got these homes that we're providing these specs for windows, insulation, targeted air tightness, and we've got, similar floor plans being spec'd on different lots. So, what happens in this case where we got that west-facing, home, and we're comparing it now to a different lot, same configuration, same specs across the board. Now we're facing those, 59% of the windows facing due south. What does it do to the step code metrics? So this is our baseline facing west, this is our baseline facing south. So our mechanical and system metrics, our mechanical energy use intensity, it goes from 68 kilowatts down to 62. That's a 6 kilowatt per hour per year decrease in our metrics. So that's an energy improvement. On our adjusted thermal energy demand intensity, we dropped, our percent improvement for the mechanical and system goes from 12.2% up to 19.7%. That's a 7.5% increase in energy efficiency on our mechanical and system metrics. Our thermal energy demand intensity drops from 49 to 43. That's a 6 kilowatt per hour per year increase on our mechanical and system metrics. That's another energy improvement just by having majority of the windows facing south. So what happens in the case when we've got, that home now configured with majority of the windows facing due north? 59% of the windows facing north. What's going to happen to our step code metrics? So now we see we've got our mechanical energy use intensity of 68 kilowatts per hour per meter squared. We actually increased by 3 kilowatts. So worse for energy efficiency. Our percent improvement goes from 12.2% down to 8.3%. That's a 3.9% decrease in energy efficiency. And then our thermal energy demand intensity drops from 49 or it increases to 52. That's a 3 kilowatt per hour per year increase. So in this particular home here, when we've got that same specs facing due north with majority of our windows, we're not even meeting step 3 performance to the BC Energy step code. So that's the thing that we have to be looking at and educating our clients on too. Building orientation is very key because if you have a project that has a lot of windows facing north, you want to be educating your clients, educating builders, say, hey, you're not benefiting from a lot of passive solar gains in this case. We might want to look at a higher performing U value for performance. Or, there's going to be something your energy advisor is going to be speccing in the way of under slab or better quality air tightness or something to make up for it. So orientation is very key. And I think I forgot to mention just the performance values for what we're speccing on this. We've got an average high-performing double glazed window package of around a 1.3536 for a metric U value, and then we're averaging around a 0.29 for a solar heat gain with that particular window package. So the other thing I wanted to touch on with the same project is comparing passive solar heat gains. I know that's a touchy subject for a lot of people in the room. So with what we have here, we got that same project facing due west with the majority of the windows facing that way. And we've got that same window package with that 0.29 solar heat gain coefficient. And we're comparing it to a project that has around a 0.5 solar heat gain coefficient window. So in this case, what does it do to the step code metrics? We get a better result for energy efficiency. It's more energy efficient. That's why some energy advisors are pushing towards going to that higher solar heat gain coefficient window. So in this case, just to quickly run to the metrics, on the mechanical energy use intensity, we're jumping from 68 down to 65. That's a 3 kilowatt per hour per year decrease. Percent improvement goes from 12.2 up to 16.3. That's a 4.3% energy efficiency upgrade on the mechanical and system metrics. Our thermal energy demand, 49 to 43. That's a 6 kilowatt per hour per year decrease. So something interesting when we compare the cooling load potential on this now, when we spec a high solar heat gain, this 0.5 solar heat gain coefficient window on this house with majority of the windows facing south or west, we get a 42% increase to the design cooling load on that house. That's a significant increase to the cooling load. And in some cases, if our mechanical contractor hasn't done his heat loss according to this higher solar heat gain, they're not going to be meeting the set point temperatures to make sure that house is comfortable too. So some pretty high risk when we're not going through, integrated design and people aren't speccing the right equipment across all the different disciplines, we can have some pretty unhappy clients and homeowners as well. Terry provided this document to me, and if you guys haven't seen this document, I highly recommend reaching out to him to forward it along. But it's from Fenestration Canada, and it's a discussion paper, and it's a new look at properties relevant to thermal comfort of occupants. And there's a lot of good, information here that you can pass along to your clients and your homeowners here as well. And there's one, really good quote that they have in here for an example on a sliding door. So a sliding door with an NFRC size of 2,000 by 2,000 millimeters has an approximate, square or area of around 3 meters squared. And a single silver glass with a relative heat gain of 490 watts per meter squared on a sunny west-facing late afternoon can transmit as much as 1,500 watts, equivalent to like a space heater. That's one patio door. Can you imagine if you have a whole wall of glass facing west, how much more heat gain that's adding in? And then if you can compare that same door with a double silver coating, around 800 watts, and then a triple silver around 600 watts. So that's the power of the solar heat gain associated with comfort too. Building envelope optimizations. So this is a project that we got, or development going out in the South Okanagan, and it's, again, a single story walkout basement. Majority of the windows on this one are facing southeast. And the builder on this one, was already being very consistent in hitting step 4 performance across the board. And they wanted to, see what it would take to get their projects to step 5. So what we ended up doing was going through the integrated design process, running some different simulations with different wall assembly types, different levels of window performance, to see what we could do to get this project to step 5. So with what this builder was already building towards, they were already building with 2x8 walls, 16 inches on center with R28 fiberglass bats. They had already upgraded the basement walls with an ICF, equivalent to an R28. And they were doing a dual fuel system. They were running an air source heat pump and a backup natural gas furnace for their primary space heating and their cooling. So what we did with one of the upgrade options, we looked at doing, a 2x8 top and bottom plate with staggered stud wall assembly. So breaking that thermal bridge. We ended up doing an advanced wall assembly. We had to upgrade the underslab insulation to 6 inches of underslab with, 4-inch radon guard. So our equivalent R value for our underslab was around an R34, I believe, on that one. And we had to end up upgrading the windows to triple glazing. With that, we were able to get that project to step 5 performance with triples. Another upgrade approach that we ended up doing was keeping that 2x8 wall as standard for how they were building, conventionally to getting to step 4. The 2x8's 24 inches on center with R28 fiberglass bats. We ended up upgrading their ICF walls to an R32 equivalent. With the triple glazing and the underslab, we were able to get that project to step 5 as well. Upgrade option number 3, we ended up doing, their conventional above grade wall assemblies, their conventional ICF. With the underslab insulation, we were able to quote a very high performing triple glaze window package. It was a passive house equivalent window package around a 0.8. And they were able to hit the step 5 metrics with going with a very high performing triple glaze window package as well. So that's the power of triple glazing as we move forward with the step code as well, to start educating your clients on the cost upgrades on those as well, and getting them to step 4 and step 5. This is another example of a project we're involved with under a Part 3 build. So this is a 6-story, 48-unit residential building going on in the South Okanagan. And the builder wanted to, they're required to hit step 2 performance, but there are some rebate incentives going on through FortisBC and getting them to step 3, which is equivalent to that 50% better metric. So there's $80,000 on the line through FortisBC and going to that standard. So again, we went through the integrated design process and we involved the window suppliers and, the subtrades to have conversations regarding, the different options that they could provide in hitting the step code metrics. And this is some of the stuff that we went through and compared. So the thing we're going to be looking at here is comparing different wall assemblies and window performance values and getting the builder to both step 2 and step 3 performance. So with one of these, we had a 2x6, a 16 inches on center with R22 fiberglass and R5 of exterior insulation. So any window suppliers or people involved in part 3 side, in order to hit the step 2 underneath the BC Energy step code, large part of the time we're seeing exterior insulation being spec'd as the requirement. So this is a very standard kind of configuration for hitting step 2 performance with the exterior insulation and the double glazed with a average metric U value around 1.42. Wasn't meeting the requirements to get them to step 3. So one of the things we looked at was that same wall assembly with R22 fiberglass, that R5 of exterior insulation with triple glazing, having an average metric U value around 0.9. That was the meal ticket in getting them to step 3 performance through triple glazing. Another wall assembly type that we reviewed was a 2x8 wall, 16 inches on center with R28 fiberglass bats. Speccing a double glazed window package with the U1.42 didn't quite meet the metrics in getting them to step 3. So when we looked at upgrading them to triple glazing, doing a 2x8 wall, 16 inches on center with R28 fiberglass bats with the triple glazing got them to that step 3 performance target. Another wall assembly that we looked at was doing a 2x4 staggered stud wall, so breaking that thermal bridge again with the double glazing. We were able to get them to step 3 with that particular configuration as well. So the developer went back and they ran the costing on all these upgrades that we looked at to see what was going to be most cost effective with their processes and their supply chain for what they could get for pricing. And with what they came back with was, option number 4, that's the one with the 2x8 wall, 16 inches on center, R28 fiberglass with the triple glazing, got them to step 3 performance. This particular configuration was around $280,000 cheaper compared to going with a high advanced, staggered stud wall assembly or going with the exterior insulation. So if you guys have projects under part 3, you notice the architect is speccing exterior insulation, chat with your developers about, hey, maybe we should look at going triple glazing with, more of a standard wall assembly. Maybe that'll be the meal ticket and you guys can have some cost savings. And having the conversations about the integrated design, which I'm going to be discussing here with you guys now. So before I get into discussing what the integrated design process is, I always like reviewing what the conventional design process is and what we're accustomed to in industry. And it's a very linear process where we've got a client who is, has a vision, they have a design, so they reach out to an architect and, a preliminary design is made, it goes back to the general contractor and they send it out to all the individual disciplines to get, design, pricing on those. And, oftentimes everyone's working in a silo approach and, there's very limited collaboration going on regarding synergies that we might have, cost savings, how it's affecting the different disciplines for what's being spec'd across the industry or across the project. And oftentimes it's emphasis on that first cost approach. So, what's it going to take to get that project to occupancy? It's that final dollar value. We're not looking at the long-term, operational costs, 25, 40 years down the road, or even the replacement costs of the products that are getting spec'd. So moving into the integrative design process, it's more of a front-loaded investment. So we're spending a lot more time during the initial design stages. We're involving the industry experts like yourselves and getting to the table to provide your input, to provide your expertise, to educate the client, the homeowners who are investing, who are paying the money so they have an understanding of, the limitations or how it's going to be affecting the project as a whole. And we really have to start looking as a house as a systems thinking approach. Much like of what you guys do in the window and door industry, you guys are already doing integrated design. You're speccing, the frames, the spacers, what type of glass, the insulating gas, to make sure that product is gonna, meet the specifications, the third-party testing requirements. You guys are already doing that, but oftentimes we're missing out on the project as a whole, how that all comes into play. So through that enhanced collaboration, we can have, the conversation with the mechanical contractors, like if we're speccing triple glazing, how that's going to be affecting, our space heating or cooling demands. A lot of times we're seeing when we're going through this, we're getting away with a lot smaller ductwork, a lot smaller bulkheads, smaller size mechanical systems. It's changing the electrical loads that are required on these projects. All that has cost savings to our client. So through these full design synergies, we can look at, the total cost as well, the return on investment down the line too. What are going to be the cost savings? If we got this increase with the carbon tax too, should we be looking at going to heat pumps, electrification? What are the implications on that too? What are the restrictions that we have? So there's a few different levels of integrated design as well. There's a micro IDP. So oftentimes a micro IDP, it's a bit of a fast track integrated design where it might only be just, the builder, the integrated design facilitator, the energy advisor, and maybe you as the window supplier, having a small conversation about how we can optimize the window package to get you guys to your metrics. An IDP Lite, that's oftentimes, a full integrated charrette where we're bringing all the industry experts and we're working right from initial design right up until we're going in for permit. We're closing out on the lessons learned and the meeting minutes, and we're moving forward and closing out that IDP. A full IDP, that's oftentimes one that's starting right from initial design. We're continuing it on to construction. We're having facilitated meetings. We're doing benchmarking. We're doing testing during construction. And then we're also, even having conversations after occupancy, having the lessons learned, doing the research on how that building is functioning overall. So a few different integrated design levels that are out there. Oftentimes we're finding this is the sweet spot, the IDP Lite for many clients out there. We touched on that house as a system concept as well. I already touched on that, but that's very important as we start transitioning through step code and we start changing parameters and we're focusing on, especially the solar heat gain. Especially if you have a client or an energy advisor who is speccing something, you've seen that coming in, very ideal to start having the conversation about integrated design, getting in front of your client and educating them on the risks and the repercussions of that as well. And the whole point of this, which oftentimes we're seeing that's getting overlooked, is we're moving towards a perfect home. And the thing that we should be looking for, making top priority, is comfort. Because if we're just focusing on energy efficiency, the most cheapest possible way to get there, we're missing out on that important factor of comfort for these homes. So the perfect home for what we're trying to achieve is is it affordable? Is it energy and is it carbon efficient? Is it healthy and safe? Is it durable and resilient? So the IDP structure is typically broken out into a couple phases, and it's dynamic. It's really changing compared to what the goal and the vision is for whatever project we are. There's not a one-fit solution. We're always trying to make it specific because everyone's time is valuable, and we really want to make sure that these charrette sessions are set up with the correct industry experts to have these conversations as well. So they oftentimes start with a client discovery meeting, then we work through the benchmarking and optimization. And then I'm going to discuss the delivery of how these integrated design sessions typically go. So through the discovery session, we're sitting down with the client and we're trying to understand the project vision and making sure it's defined and getting towards what the ideal target is. And we're laying out the project goals and their constraints. So we're going through and we're trying to understand what their typical, conventional building practices are, and then looking towards identifying, what they want to see benchmark and who those industry experts that they want to bring into the mix to have those conversations. Then we move into identifying the integrated design team. That's also very important. What designers are we bringing in? What contractors? We should be getting the people who are actually in the field, seeing these products getting installed, getting their input on some of the, the challenges that are being faced, even if it's, how these windows are getting installed, the specs, and the flashing details as well. Getting the, input from the actual installers that are in the field too has been very beneficial in these sessions that we have done. We then go through laying out the benchmarking and optimizations, whether they want to try and hit, step 3, 4, or 5. And laying out the charrette agenda development as well is also very important for laying out the pathway for these discovery sessions. So as we move into benchmarking and optimization, this is when we get into integrative energy modeling. So that's working with the registered energy advisor from under Part 9. If it's under Part 3 of the building code, it's that energy modeler. Going through the different pathways and looking at the benchmarking and costing methods there too. There's several tools which I'll go over coming up as well that are available to industry to take advantage of to run multiple simulations and costing on these different options. And during the benchmarking and optimization pathways, we're also looking at engaging the mechanical designers, getting their input on the mechanical design and the loading of those systems as well, because depending on what options that we're sizing for upgrades, that's going to be affecting the mechanical systems as well. So we're oftentimes looking at upgrades to the windows, going from high-performing doubles to triples, looking at what type of building envelope materials, whether it's exterior insulation, under slab, raised heels for trusses. Optimizing the mechanical systems. Are we going with heat pumps? Are we going with boiler systems? Are we going to air-to-water heat pumps? And then oftentimes we're targeting very airtight homes. What type of ventilation systems that we're speccing as well? So there's a few different costing tools and benchmarks that are out there to run these simulations as well. And National Resources Canada has a process that runs through HTAP and their cost-benefit analysis tool too. So NRCan has released a pathway where we can take our HOT 2000 program that we use for the energy modeling under the Part 9. HTAP can run thousands of different energy modeling simulations, and we can run those through the CBAT tool to compare which one is the most cost-effective. And then, for building, getting to occupancy, and then also for operating costs per year and replacement costs. So they've got some really good tools in regards to that CBAT tool that was released by National Resources Canada. The delivery of these sessions can be done online through Zoom, Microsoft Teams. They can be done in person or even on the job site. The integrated design facilitator, they're the ones who are involved in facilitating the meetings. They're taking the meeting minutes, and they're also documenting the lessons learned so they can be passed forward to other projects. Context setting is very important, making sure that we've got an agenda that we're sticking to, because sometimes these meetings get out of hand, and we don't want to be wasting people's time. Overview of target and direction, and presenting the benchmarking and optimizations is what's also taken on in the delivery of these sessions as well. So FortisBC does have design offers in helping cover some of the costs for this as well, underneath Part 9 of the building code. And they've got up to $7,000 in rebates, and that's per particular unique floor plan. So if you've got a development going on, there's 10 different floor plans, there's up to $70,000 that up for grabs there. $1,000 of that goes towards integrated design process, and then up to $6,000 can go towards the building envelope consultant or the mechanical designer to be engaged in running their services as well on these. So Fortis has got some really good incentives going on. And then just to recap, who is the IDP for and who does it benefit? It's everyone. It's our client. Right? So it's getting the industry experts, getting the suppliers, getting the people, because, the last thing we want to see is, we're getting these projects to basically lock up, and we're getting our industry experts to the job site, and they're walking on and they're saying, oh, this is what I would have done. Because if those conversations are happening at like lockup or mid-construction, it's already too late. Those conversations have to be had during the initial design. And I'll leave it with that, and if you guys have any questions, I'd be more than happy to answer them.
Anybody? Alan, hang on.
Yeah, thanks for the presentation. One factor I saw, do you guys consider the window-to-wall ratio in conjunction with the particular solar heat gain target that you're using? I'm just saying as window and wall ratios increase, then the amount of that free energy starts to grow proportionally. And does that have a factor in the solar heat gain target that's being designed for?
100%, and also direction of orientation. So the window and door to wall ratio windows are your weakest link in any project. So orientation of, like we reviewed in that one case with what they're facing, dramatically affects the step code metric. So if we are having a project that has very high window and door to wall ratio, oftentimes we're having to spec triple glazing in order to hit the step code requirements there too. So
This is more of a question out there because it's like a black hole, but I'm sure you've dealt with it here in Kelowna because we've seen it in Vancouver and West Van, and that's refracted light and heat from that off the ocean, off the lake. And I'm just wondering, with orientation kind of playing a role only from the sun, is there any thought or consideration that we want to put forward to say, hey, like this is an issue that is actually happening?
unfortunately, with the modeling that's taking place, those discussions are not being had on our level. That would be something good to bring up with the safety standards branch as well, people like Scott too, because that is a very factor that's not being taken into account. And even on the Part 9 side, we're factoring that project is sitting in an open lot with no trees or anything surrounding it either. So it's a line comparison to compare all these other. But for what you're talking about, that's a great topic to bring up.
Most of the manufacturers in BC are pretty familiar with the step code, and something that I think certainly I found when I was dealing with it was that your windows became a much better cost option. When you get into high performance windows, it can have such a much bigger impact on the performance of the home than a thicker wall or more insulation in the ceiling. And we found that pitching the cost for a triple glaze system or a high performance system actually became a much better cost benefit to the builder. So something to think about when you get into these home performance, home as a system kind of scenarios with step codes and tiered codes, which are coming your way if you're not here in BC.
Yeah, that's a good point there, Terry. And I'll just touch on what we're seeing in some of the Part 3 side too, is we're getting the building envelope, consultants specing this exterior insulation. We're getting like these effective, R25, R28 walls, and we're still installing like a metric U value of like 1.6 for double glazed windows. And like your weakest link is your windows. So that education has to be getting back to the builders and providing those cost upgrades, because, investing in windows is, when we run the costing analysis, it is considerably a factor in getting to your step code metrics cost effectively.
So right now, I think the problem for window fabricators is we are downstream of this process. And Anton from Centre was just complaining to me last night about, they get the energy advisor report that says they want a really high solar heat gain window, and it's a rental property. And and what's going to happen is they're going to get excessive solar heat gain, and then they're going to put insulating blinds on the inside, and then they're going to melt the vinyl windows. He brings all this up, and it falls on deaf ears. But so this process is a bit of a revelation to me. So how do we introduce this to our customers? Because we're generally downstream of this process. So do you have any suggestions?
It all comes down to education, right? And I think there needs to be more education brought to consumers and also to builders in regards to the high solar heat gain, right? And, educating them on the integrated design, getting you guys, industry experts, to the table to have discussions with the energy advisors, and educating the builder associated with the risk of this stuff too. So it's a bit more of a time sensitive issue, I know, for cost and everything for the front loaded investment, but that's another way how we can alleviate that too.
So solar gain is obviously a big topic here in BC, but I'd love to hear from others east of the Rockies that are using solar gain effectively. So if anybody here has that opinion, I'd love to hear it.
I do have a question, but to comment on Dave's comment that I made last night, the calculations you're doing are whole building calculations. They're not room by room calculations, correct?
That is correct.
So that's a scary consequence, because small rooms overheat more than big rooms. Small rooms have less cooling load, third floor. I grew up in a house that second floor west facing window. Mm-hmm. Slept in the backyard all summer as a kid in a tent.
But you grew like a weed, man.
Yeah. So this is where I talk about people is there's whole building performance, there's room performance, there's product performance. And our industry is talking about product performance. Mm-hmm. Nobody else is. And so when someone goes on vacation, what do they do with a house that's using cooling? They turn the AC off, close the blinds. They come back, they open the blinds, and there's a consequence. But my question I have for you is, Who determines the duration of heating load and cooling load on a home? I had a project recently where they claimed a 6-month heating load versus a 1-month cooling load. And I went, where did you come up with the concept there's only a 1-month cooling load? Because my experience in Vancouver is it was 30 degrees last week.
Yep.
So May, June, July, August, that's a 5-month cooling load in the city of Vancouver, potentially, or more as the climate gets warmer.
Yep.
But the energy advisor's position was it was only 1 month of cooling, therefore high heat gain was an insignificant impact on the overall building performance. So who is determining, is that a thing in Hot 2000? Is that based on regional components, or is that just a subjective determination?
So that weather data is coming from National Resources Canada for what that's being pulled in the model. So I know that there are conversations about updating that weather data too, because it is not realistic for what's being currently played, because we do have that climate change that's happening, especially here in BC. We're noticing hotter summers. So that is being in review, but still at that time, we're still off that weather data that's from National Resources Canada. So
Just one follow-up to that too. The common, your energy modeling reports you showed are great because they say they have a number. There's not a or higher. And what are your thoughts on energy advisors that are specifying like a 0.3 solar heat gain or higher and not putting an upper cap on solar heat gain? So they could be getting a 0.5 and not being aware of it. Are you like, how do we deal with those situations where there's no upper cap on solar heat gain in an energy model on a home?
That is tough. We also don't want to solar gain for certain windows, right? Because when we get into step 5 passive house homes, if we've got the right overhang, so in some projects like looking above like a 0.3 solar gain will benefit the model. But it's if you're just applying that to all windows, you're running into detrimental effects. So I can't speak to where that's going to come into play. I think from what Scott talked on, looking at the cooling load and how that's being factored in as well to make sure that we're speccing and we're not over-speccing the solar heat gain is going to be a great way. But I'd like to say is like we bring it into building code and we say like 0.3 is the max, but then we're not favoring passive house designers who like those high solar heat gain when they're building those homes properly with the right overhangs, or if we are in the northern regions as well. So it's a bit of a tough situation to combat. I totally agree with you, Anton, but typically for us, we're not speccing anything over 0.3 for us, because especially here in the Okanagan, there's detrimental effects that happen in the summertime.
Do we have any numbers on the metrics used for putting, say, a tint on the window, a gray or a bronze tint, to mitigate or bring down the solar heat gain coming in and helping the home to be more of a passive on that? Is there any numbers on that metric?
So like afterwards, after those windows are installed, putting the tints on after, is that what you're getting at?
No,
or?
during the manufacturing process. And yes, we could do it also after that process as well, but during the manufacturing process.
Yeah, so like we all base it off of like an NFRC or the third-party test data, which is looking at the standard sizing for the U-value solar heat gain coefficient. That's what we're putting into our model here as well. So yes, adding that additional tint does reduce the solar heat gain as well.
Hi there. For projecting windows for passive house step 5, the path for most of us is going to be surface 6 low E, which isn't really come into play in Vancouver, in the Okanagan, but if we get into northern BC or sort of into colder climates, what's the discussion around the condensation? That's the problem, because I'm east of the Rockies, and surface 5 or surface 4 low E is a real problem for condensation in certain of our areas. So I was wondering if that's any on your guys' radar at all or part of the conversation.
No, that's a great topic to bring up. That hasn't been on our topic here locally, but again, that would be a great topic to bring up to the safety standards branch and people like Scott.
I've got somebody that can talk about it.
Hi, I encourage you to take part in my presentation this afternoon at 1:45 because we're going to talk about summer and winter glass surface temperatures under NFRC conditions for the various insulating glass options. And you're asking a very good question, an important question, and that presentation will be relevant to what you're interested in.
Hi, there's a lot of talk about solar heat gain, U values, that sort of thing. But to go back to building envelope air tightness is obviously a critical part of this. I live in the lower mainland of British Columbia. There's still a lot of sliding windows. Has there been any studies, sliding windows versus hinged window product?
Sorry, say that last section again. Sliding
So,
windows.
so he's asking about comparative analysis on sliding windows compared to casements or tilt-turn systems and the air leakage issues
yeah, like
or concerns.
anytime we're testing those, when we're doing the whole building air tightness testing, we always see leakage associated with sliders. Comparing it to like a lift and slide patio door or casement windows, those always perform better. But again, like we've done projects with full sliding glass, doors and windows, and we are still consistently hitting our targets. But sliders are always a weak point for air tightness regardless with OSASH. So.
The other issue with solar gain and the benefits of solar gain is anybody that's lived in Vancouver for more than a year knows that there isn't any in the wintertime. So anybody that's using solar gain effectively, I know it's pretty popular in central Canada, high solar gain products. We see them everywhere. Just wondering if anybody has any thoughts about effectively using solar heat gain in their products. All right. Overhang. Overhung? All right. Once, twice? Thanks, Brendan.
Awesome. Thanks, guys.
Thanks a lot. Okay, we're breaking for lunch, and then after lunch,